Okay, eighth graders. Yesterday we talked about deductive reasoning. It's going to come up for the Math 8 students with all our work on parallel lines and transversals, our work on the Pythagorean theorem. For the Math 1 students, it's going to come up for our whole unit on triangles and looking at different kinds of theorems about triangles, really fascinating and beautiful theorems. For the Math 8 kids especially, there's another form of reasoning, though, called inductive reasoning. And that's going to come up with our work on statistics, on scatter plots, on tables. And it's a whole different way of looking at mathematics. And I want to start, again, at the beginning, big picture here. And the big picture really is that with inductive reasoning, we're not starting from any kind of like big first principle, any claim that we can take to the bank. All we have is a bunch of information that we've gathered. And here's one example. We have a scientist at Botswana National University in Africa studying the numbers of zebras seen together in groups. Exciting for her. Good reason to stay in school. Great job studying zebras. Okay. So this person finds that the mean group size of zebras seen together is, I don't know, what do you think it is? Just for fun, I'm going to say, here we go, 6. It doesn't matter though. You could just as easily say 7 or 9 or 52. But she observed 6. Okay. So based on this information, she looked for a pattern. She found at least one pattern. This is the mean or average group size. And so the conjecture might be that she would find it surprising to find a group greater than, what do you think? You think it's 6? Would it be surprising to find a group greater than 7, of 8, of 9? At what point would you be surprised, ladies and gentlemen? At what point do you think she would be surprised? Now, I don't know. We would need something called the standard deviation, at least, to know the answer to this question. But let's say, educated guess, maybe 9. Again, we need more information, but it's not going to be a number drastically different from 6. Okay, so that's a conjecture. All right, so this comes up also in a different kind of problem. So here's a more traditional math problem. Again, here we're not starting with a firm statement. There's no equation here. Instead, we have the following sequence of numbers. For instance, 2, 5, 10, 17, 26. And I'd like you to look for a pattern. A pattern. Think about it for a sec. I'm not going to test you on it, but I'd like you to hunt it down. All right, so like one thing I noticed, for instance, is that the difference between 2 and 5 is 3. The difference between 5 and 10 is 5. This is 7. This is 9. So that's intriguing. Some of you may have noticed that 1 squared is 1 plus 1 equals 2. 2 squared equals 4 plus 1 equals 5. Let's see. 3 squared plus 1 equals 10. So that might be another way to look at the pattern. Either way, we're not necessarily applying logical operations that we can take to the bank here. We don't know for sure that this sequence is going to continue, but if it does, we would predict that the next number in the pattern will be what? Did anybody guess 37? Maybe so. So what I would like you to do for this last day of kind of like pre-work homework is to come up with an inductive reasoning pattern of your own and submit it on Google Classroom. So you could make one up that's kind of whimsical, like my one about the zebras. You can look for a sequence and think about the inductive reasoning to find the next number in the sequence like we did down here. Either way, it doesn't matter. I don't want you to work a long time on it. But I do want you to think about this as context for what we're going to start in on in earnest at the beginning of next week. Once again, I hope that everyone is staying well, that you're not having too much cabin fever, that you're finding time to exercise. Be grateful to your parents. They're working hard for you. And I'm looking forward to seeing you again or talking with you again next week. Take good care.